Now, when you have a targeting system, there's probably going to be a slew of scenarios in which you want to swap between targets. So we're going to add that as well, but before we do, we need to do a little bit of prep. So in the enemy BP, we're going to add a collision sphere. I'm going to call this ray collision. And let's go head over to viewport and just, oh, did I choose capsule? I meant to say sphere. And ray collision. And I'm going to put this like right over his head. And the size is fine, just want that there for later. We also want to set this one to custom and ignore everything. No collision, ignore everything. Yeah. Now let's head over to the overview and go into settings and project settings and down to input. Let's see, action mapping orbit axis. Yeah. So I'm going to go ahead and remove up and down, and I want to remove the left and right as well, because I don't use those inputs to move at all, so I don't need them there. In fact, I want to use the directional keys to for something else. So with that done, we can come back into third-person character. Let's scroll out or zoom out and find some empty space over here. And I'm going to add an input for left, right, up, and down. There, let's organize these as well, or just line them up so they look all pretty and neat. And we also want a new variable, so come over here and just add new variable. And I'm going to call this swap direction. And we want to change this over to an integer. We can add a set of this here, and we want to copy this down so we have one for each input. And likewise, we need to differentiate these. So this top one can stay at 0, but we want the following ones to be increased by at least 1. And we can just connect these to pressed. We also need a branch over here. And we're going to connect all these into that. Again, to add a reroute node, you just double click on the line. And again, this is going to be a target locked condition. And we need a... Okay, let's just come over here, find this. Well, both of these actually. Just select those. Come back and Control W to duplicate them. And what we're starting to do here is we're adding, we're starting to add logic for to differentiate which way we want to swap to a target. So if we want to swap left, we have one set of things that's going to happen. Right, another, up and down. Now, up and down is not actually up and down. It's up is an enemy further away, and down is a enemy closer to you. And we're saying we don't want any of this to happen if we don't have a target already. So with that done, let's just come over here, and we are going to add even more nodes. So let's get a set of target distance and a get minimum distance enable and plug it in here. Let's just move these a bit cleaner. And now we want to make another new variable, and this one we can copy off nearest target. Just select it, duplicate it, and we're going to call this current target. And we want a set of that here. Let's just get it out there and a set. And we want a get of our nearest target and plug it into current target. And we're going to add a get all actors of class. And like before, we want this to be enemy BP. The next one we're going to do is add a for each loop. And we can see we're starting to get a little bit closer. So let's just grab all of these and move a bit further away. I think that's good. Like with the other for each loop, we can add a enemy element here. Set. Let's plug these in as well. Just these are connected, and get this in here. And the next thing we want is a line trace for objects. So let's pull out here. And you've probably noticed that this here looks a lot like this over here, and that's because it does very similar things. So let's get a copy of enemy element. We're going to need a get here, and from out of this we're going to pull out here, and we're going to say ray collision. We're going to get that array collision we added to the enemy blueprint, and from that we're going to say get world location. We're going to plug that in to end here. Now for our start, we're actually going to promote this to a variable. Let's get this down here, and we're going to call this start vector. But for this to actually do something, we need to set this start vector somewhere. And we're going to do that over here, actually, right after this input. So just pull that away a bit, and we're going to say follow camera up here. We're going to grab this, pull it out, and drag out of it, say get world location. Move this a bit back. And we're going to split this structure. We want a float plus float. We're going to call this plus 200. And plug that into the set value. And we want a make vector node. And we're going to plug the result from this float plus float in here, and the other two in like this. And actually we want even more space. Just select all these, pull them out. Here we go. And in between here we want a set start vector. So let's just pull this out here and say set. That's easier. And we'll move this this connection here by holding control, just dragging that across here and connecting it back in. And we're going to set the result of all of this into the start vector. And what this does is that it sets the start vector location to be a point about 200 units above your camera, so above this thing. So it's going to be like about here. And the reason we want that is because we don't really want the line trace to start from the center of your character as it does right now, because a lot of things can obstruct that view. So it's better if it comes from somewhere where the view is the trace rather is less likely to be obstructed. And because we create this here, we're also going to set this down here. So we're going to replace this get actor location with start vector. So we can just plug that in here. So we're basically fixing something we did in the previous video. And we already have this over here, so that's all good. Now let's add a make array. And we're going to have 2 pins here and plug this make array into actors to ignore. And the actors to ignore is our current and target. So let's get that. And our nearest target. Let's get that and plug both those in. We also want a copy of target locked. Let's grab that, select that, come over here and duplicate it in. And gonna say, yeah, this one's nearest target as well. And we're gonna plug this into complete for, or completed for each loop. Let's do that there. And we also need a object type for this line trace. So we can just come over here and grab this one. We're gonna be the same one. So again, Control W to duplicate the selected node. And we want a break hit result, so just pull out of out hit, say break hit result, and press hold B and press left click. Plug these together and say equal objects plug hit actor from break hit result. And we want a enemy element as our compare here, and this will be the condition for the branch. And again, we're getting a bit close, so let's grab all of these and let's just move them way away so there's no chance of colliding anymore. With that done, we're going to add a switch on int. Let's see. There we go. Switch on int. Gonna plug that into true here. And for our selection, we're going to get a copy of swap direction. So just plug that in here. And we're going to add 4 pins here. So we have 0 through 3. And you can leave this default here. I'm going to remove it. And to remove it, I just come up here and click here. And for these results, we need to add some custom events. So let's do that. We need 4 custom events to be specific. The first one I'm going to call enemy to right. I'm going to duplicate that and double click on it. Call this enemy and to me to left. Duplicate that. Call this enemy further. And the last one, enemy closer. And yeah, these aren't going to stay here. We're going to use them later. We're just adding them now so we can pull out results from this switch on int. And to know which of these are going to be connected, or which of their calls are going to be connected to which of these, we're going to have to go back here and look at this. So we can see that 0 is left, 1 is for right, up is 2, and down is 3. So we're going to pull this out here and say enemy to left, and 1 was right, so we're going to say enemy to right on that. And my short-term memory is faulty, so I need to check again. Up is 2 and down is 3, so 2 is going to be further, and down is going to be closer. And with that done, it's time to add the logic for what decides what's left of your target. So let's grab this custom event, just zoom out and just come down a bit. We don't need to get that far down. This should do nicely. Just put this right here, just as an anchor point of where our logic is going to be around. And we're going to get 2 world transform nodes. So get world transform, and we can start with our camera boom. We're going to split this pin structure like so, and we're going to split the rotation even further. And we need 3 of these, so just grab that and duplicate it twice. And actually, I want to do this just for cleaner connections later. And for our top get world transform, we want a copy of our enemy element. So just grab that, put it here, say get, and we can't plug this straight in there. Well, we can, but it adds a capsule component in between, which is why we can't just grab it and say wooha. So just place it in the grid first and then plug it in afterwards. And we want a get of our current target as well. So just grab that, get a get, and plug that in here. All right. And now we want a find look at rotation. And we're going to duplicate that as well. I'm going to put that down here. And our return value from get world for enemy element is going to be plugged into target on our top find look at rotation. And the same for our current target element for the bottom find look at rotation. And then our camera boom is going to be plugged into start. And we want another copy of get world transform location, actually. So let's just get that. And this one is going to be for our follow camera. So just grab that, plug that straight in here. And now we want to split the pin structure for both look at rotations. Just do that. And we want a 2 float minus float nodes. So just get one and duplicate that with Control W. And we're going to grab yaw from our top first find look at rotation. I'm going to plug that in here and grab the yaw from get world transform for follow camera and plug that into the bottom of both of these minus floats, and get the yaw from the bottom find look at rotation and plug it into the top of the bottom float minus float. And now we want a float plus float. We're going to plug these in here. And next we want another one of these plus, so just add that here and duplicate it rather. And I'm going to plug the top one from this plus in here, and we're going to say 360 on the bottom. Excuse me. And we're going to add a greater than float. And we're going to say if this result is greater than, or is less than 0, we're going to get a condition out here. So for that condition, we need a select float. So let's get that. There, select float. And we're going to say this top result here is going to go into A. Bottom result is going to be into condition, obviously. And we're going to plug the center in here. So let's just put these like that so they don't overlap. And you may have noticed there's a lot of math going on here, and that is because you need a lot of math and vectorizing and such to figure out which direction is with which direction compared to several different actors in your game view. Now, from this select float, we're going to add a in range. There we go. And for these values here, we're going to set something specific, which I've written down somewhere. Hold on. And yeah, it's going to be 270 for minimum and 350 for maximum. And I'm going to try and explain these values later, but for now, just add them. And we need a branch, so hold B, left click, and we're going to use this as our condition. And for this branch, we need our enemy to left. So let's just grab that and plug this in here. And now we need to add something else before we can continue out here. So let's just scroll out again. Yeah, let's go up here, and we're gonna add yet another custom event. So do that, and I'm gonna call this check distance, and this is gonna be very similar to what's happening over here, but not completely the same. So with this custom event created, let's add a branch, hold B, left click. We're gonna add a get distance to, and gonna say get distance to enemy element, and we're going to compare this to our minimum distance to enable. So drag out of the return value and add a less than float, and grab the minimum distance to enable and just plug that in there. And this is going to be the condition for our branch. And with that done, we're going to add a compare float, and it's going to come into plug out of true from the branch, and we're going to get another distance to. So just grab this, Control W to duplicate. Actually, let's add some space here because we don't want things to be too cluttered. And we're going to get a current target into the top of this get distance to, and a enemy element into the bottom, like so. And I'm going to plug this into the top here and get the closest target distance and plug that into the bottom. Then we're going to get a set closest distance, plug it out of the less than, and we're going to set this return value as closest distance. And finally, we want a set nearest target, and we're gonna say enemy element. Now, what this string does, or what this string of logic does, is it checks if the enemy element you're currently looking at, or is currently going through the line trace, is within range for your lock-on system. It then compares it to your current target and checks how close it is. And once all the enemy elements have gone through this this logic, the only one left is going to be the enemy that's closest to your current target. If that makes sense. I hope it does. It does to me. And with that done, we're going to add a call to this check distance down here. So just grab out of true and say check distance. And with that, we should be able to use our left directional key to swap to targets on the left. So let's compile and let's check if that's true. So once we've compiled, hit play, and we're going into the game view. And let's now, since we've only added logic to for targets to the left, we need to pick the rightmost target and hit T to lock on. And when we hit the left directional key now, we should swap over to our other enemy. So hit left key, and yeah, there it is. Now we can swap to left targets. All right, jump cut. So I'm going to attempt to explain what's going on here. If you don't care, just skip ahead, but if you do care, let's get into this. So to determine what's to the left of us, which is what we need in this case, we first need to define what left is. So in order to do that, first we're using the camera boom and the camera rotation and our current target to create a vector with the rotational value of 0. We then compare this vector to a vector created between our camera boom, full camera, and other enemies, and subtract that value from our 0 value to get a new rotational or float value. Now, Unreal 4 measures rotation in 0 to 180 and 0 to a minus 180. The plus side being what we perceive as right, and the minus side being what we perceive as left. I then convert that the value we get between minus 180 and plus 180 into 360 degrees. The reason I do that is to avoid some bugs I ran into if I didn't do that. But we still haven't defined what left is in game, and that's what we do over here. I want the game to consider what's in the degree range from 350 to 270 relative to the camera to be left. So that's what we do here. If you want, so if you have understood what I've said now, or if it's made sense, you'll see that 360 and 0 is pretty much the same thing. Both of those directions are forward. So if you wanted to, you could say that it should be 360 to 270, which would be 90 degrees or from right ahead and 90 degrees to the left, and consider that to be to the left. But I want a slight gap straight ahead to be just considered forward and not considered left. God, I hope that made sense. Next, we're just gonna select all of these, and we're gonna deselect the custom event, and we're gonna come down and just Control W to duplicate. Whoop. Let's try that again. There it is. Just line it up, and we can go ahead and grab our enemy to the right, or enemy to right. Put it down here, plug it in, and we need to change these values here. So minimum this time is going to be 10, and the maximum is going to be 90. Oops, 90. There we go. And just compile that and save, and that's it for selecting enemies to the right. You can test that if you'd like, but I don't think it's necessary here. Next, we can pretty much just do the same thing over again. Just select all of these and deselect the custom event, come down and say Control W. But this time we need to add some more nodes. So let's just move this out of the way, and we're going to add a new branching node. Plug that in. Oops. Plug that in between these two, and we need a new in range. And we need a let's see. I'm going to pull out of the return value on one of the in range. I'm going to say OR. We want the OR boolean. Oops. Clumsy today. And that's good. And we over here we want a get distance to. Actually, we want to get distance to. And we're gonna put a reference to current target in here, and by reference to enemy element in the bottom other vector. And here we want a less than float. We're going to plug that condition in here. So with this logic, we basically have to say the next custom movement we want to select is enemy further, because what's happening now is that this range of values, which we also need to change, by the way, to 0, 20, and to plug this in as well to let's make it 340 and 360. Yeah, what these new additions do is say that enemies in front of us, we want to select the enemy that is closer to us, but also closest to our enemy target. So no, close to our closest to our enemy target, but also further away from us. That's what we're doing, and we're going to test this in a bit. But we might as well just finish the last direction for swapping as well. So let's do that. And to do that, we can just select all of these and duplicate them down. And oh, I forgot to deselect the custom events. So if you do that, just delete the copy, and I'm gonna come up and grab the one we made earlier. And all we need to do here is to replace this, and what we want instead is a greater than float. Alternatively, you could swap the connections. It would really do the same thing. And these values are going to be the same. So just compile that and save, and now let's test. For when we want to test, we first need to add some more enemies, so we have different enemies to select between or swap between. So let's just grab a few enemies, and alt enemies if you like, and just place them around so we can see how the swapping works, or if in fact it works. Like so, and just hit play and press T, and you get your first closest target. And we can see swap further, swap closer, left, right. Yeah, so that seems to work. One thing you may notice while doing this is that you can't really quick swap in one direction really efficiently, and that's because while the camera is still transitioning, the values will how do I explain this? While the camera is transitioning, it's the point in the transition in which you press the new swap, the system will consider to be the correct direction, if that made sense. I don't think it did, but anyway. This works. You can, in situations like this, you might sometimes end up with further being the one that's to the right here. So that would be this one. And if you don't like that, you have to go back into here and say that in front should be a narrower range. So you might put this to 10 instead, and likewise put this to 350. But if you think it's fine that sometimes forward is that one, then you can just leave it like that. Okay. So before we move on, we're gonna have to do something about the camera lock-on, because as I made it originally in the original lock-on camera video tutorial, I didn't really do it right, and I'll show you what I mean. Because in that video, I didn't lock the pitch axis for the camera, which makes for an awkward scenario if our character is elevated or on a lower plane than we are. Let's. I'm going to show you what I mean. So here, if I lock on to this dude, and now I want an enemy that's further away, this happens. The lockdown enemy isn't on screen. That's because he's up there. And the camera doesn't follow him because I didn't lock the rotation of the camera in the pitch axis to the target. And to fix that, we're gonna go ahead and move over here. We're gonna go into this camera rotation node. We're gonna see over here. We're gonna remove this connection and we're gonna replace it with this. And now that should be fixed. So we can lock on again, find this one, and go up, and you see the camera rotates with our target. However, now we're revealing a different flaw in the setup, in that the camera position right now isn't really all that good. So what we're going to do next is we're going to fix that. So first of all, we're gonna, well, we need to go back to the event graph. And then we want to change this mouse input, which controls the camera. The same would be true if you've made this situation on the gamepad input as well. So we just copy this branch here, we delete these two nodes, and move this over here, basically making it the same as the one above. So we have no control over the camera in the pitch axis. God, that word is so hard. Next, we're gonna go over to viewport, and we're gonna add something here. We're gonna add a sphere or a sphere collision. Doesn't really matter. And I'm gonna call this boom anchor. I'm gonna make the size of this smaller. Is there not a radius thing for this? It doesn't matter. We can do it in scale. So just make it small. And I'm going to move this up to about head size. That seems head size, location. And the same for camera boom, because looking at our butt isn't really what we want. We want it to be higher, or at least I do. So I'm going to move it to about the same location as the boom anchor. The next thing I'm going to do is, with the boom anchor selected, I'm going to go over here and say hidden, and I want to set it to hidden in-game because it's not supposed to be visible. All we want from this boom is the location for the logic we're about to set up. So now we can start and add logics. Just go back into event graph, and we're going to go up here and find some loads of empty space, and we're going to start by adding a get world transform. Oops. We want the one for capsule component, and we can just, we're gonna go ahead and split this pin structure, and I'm gonna duplicate this down and add a follow camera to this one. So what we're gonna do now is we're gonna make a system that we're gonna make a system for the camera that basically makes the camera never want to be right behind you. So you're never gonna look straight into the back of your character. The camera's gonna be offset a bit, and it's gonna offset both to the left and to the right, depending on how the camera is rotated compared to your character. And the reason we want to do that is basically because it gives us a better overview of, or it gives us a better view, really, because with the way things are now, the character is always going to obscure part of your vision. I mean, it still is, but your character is going to obscure less of your vision once this is done. So again, right now we're making a the logic right here is going to determine how your camera is rotated compared to your character. Oops. So you can probably recognize that we're making it into degrees again. I don't know if I said that. Bears repeating if I didn't. I'm gonna get a float times float here. And this next bit is basically going to make it so that the camera transitions smoothly from the different positions it's gonna offset between. It's a bit tough to explain this the system because I don't fully remember my train of thought when I made it, which means I don't fully understand the system, which is a bit weird because I basically made a system that I don't understand. I just know that it works because I've tested it. But yeah. Put this to 2 and get another minus float over here. Put this down a bit. Oops. Get a select float. Put it down here. And plug that in here. And add rewrite node to clean it up. And we're gonna get another float, less than float. I'm gonna say basically gonna say if it's greater than 90, we want to use something else. So for this, when the camera gets offset, it's sort of based on rotation, and the reason we this looks like this is because when the offset gets to greater than 90 degrees in offset, we wanted to start translating back towards 0. And we do this in order to again keep it from, you know, or rather make the transition smooth, because if you didn't do that, it would just translate or offset to a maximum point, and after that maximum point it would pop back to another offset rather than going smoothly between the two main offsets. You guys copy this down. This section is basically going to be the opposite of this section above. Because if you remember, when I tried to explain the swap system, the rotation that Unreal 4 uses is from minus 180 to plus 180. So we're basically saying that the offset from the minus side is going to go to a maximum of 90 and then go back, and the offset on the plus side is basically going to go to a maximum of plus 90 and then go back. I'm gonna copy this down. Let's say minus 90 here. Ooh, that looks bad. Don't like that. Is that another rewrite node? Let's see here. this is going to be the condition here. Drag this up a bit and put that in here. And duplicate this down. And now we're going to duplicate this over here if it wants to. There it goes. Again, if you've forgotten, Control W to duplicate. I'm going to get the values of these two select floats into this new select float, and I'm going to take this and say float plus float. There we go. And this number here controls the starting offset. So if memory serves, plus is going to be on the right side and minus is going to be on the left side. So basically I'm saying I want it offset to plus 20 on the from the get-go, which is going to be offset to the right. And with this, I'm going to go times float. Oops. Set it to 2. And here we're going to get a new get world transform. And this is going to be for the follow camera as well. And there it is. Again, we want to split this split this pin structure, and we're going to drag off pitch here. I'm going to call that float times float. Let's say -1, and this is going to start going into oh, we've run out of space. Put it way up here. This is going to start going into the offset on looking up and down. You may have noticed in some games when you look up and down, you can't really look fully up and fully down. This is basically going to take care of that, making it so that when you try to look up and down, the camera will be offset a little bit so you can actually fully look up and fully look down without your character getting in the way. And here we're gonna use our anchor for the first time. And from the anchor, I'm gonna get forward vector. Oops. And we're gonna get, actually, let's pull out of this and say times float. We're gonna times these together and leave that for now. And we're gonna come up here and say we're gonna get another boom anchor, and we're gonna get word location, and I'm gonna get a copy of forward vector and just duplicate that up here, and we're gonna get right vector. Put that, drag that a bit down, and we can drag off this here and say multiply again by float, and we're gonna multiply it by this float here. Then drag out here and say clamp vector size and to a maximum of 80. That is gonna clamp how much we can offset the camera in full. And next we're going to drag off here and say again multiply by float, and the one we want here is the one way over here, so just get that, drag it across. And next we're going to get a vector plus vector. I'm going to duplicate that as well, and we're going to plug this into the clamp, and we're going to plug this into top here, and from the this one down here, I'm gonna plug that up here. Now we're gonna add another plus vector, so just duplicate that, and gonna plug the bottom one in here, and gonna grab the top one from boom anchor, and we need a transform interp there on this one, and we're gonna split pin structure on both current and on target and on return value. We're gonna drag the result from all our math into our target location, and the current location is going to be from our camera boom, which is this line here. Just, yeah, you can see that. And we're gonna get a set world location over here, and we want that to be our camera boom. We're gonna set the new location for our camera boom, which is gonna dynamically change because of our math. But we need something to drive this as well. So we're just gonna set up a new custom event, and I'm gonna call this dynamic camera. Plug that in here, and we need a call for this. And because we want it to be, we want this to be active all the time, we're just gonna come down to our timeline, and we're going to, well, let's move these first, and we're going to drag off of our timeline and say dynamic camera, and just plug that in there. So now it should be driven all the time, and unless I've forgotten something, this should now work. So let's compile and play. Yeah, now you can see, well, it's a bit jittery because of all these enemies around. So we're going to do something about that to make it, you know, not pop as much. But you may notice we're not moving up and down. And that's my fault because I've forgotten to do something. So let's hit escape and go back, and down on the mouse input we need to actually plug this value in here. So let's compile again, play, and now we can move the mouse up and down. So let's just move up here for a bit so we can avoid all the popping. And you can see if we move the camera to the side or to the right, our character is going to be offset to the left, or vice versa. Our camera is going to be offset to the right, and if we move the camera the other way, we're going to be offset the other way, which is nice because then when we lock onto someone, like this dude here, our character isn't right in front of our target in most cases. I mean, there's always going to be some cases in which it happens, but mostly our character is not going to be right in front of our target, which is nice. And also, if we want to look straight down, we can do that, and we can look straight up, which is nice, because I really hate it when games don't allow you to look straight up. It's really annoying to me. Now let's deal with the popping we see when we are down around enemies, because that's basically the enemies and the camera boom arguing about what needs to happen. So let's deal with that. So to stop that popping, we need to go over to the enemy blueprint, and we need to select capsule component and go over here to the collision, and we're gonna set this to custom, and we're gonna have it ignore camera, and we need to do the same for the mesh. Go over, go to collision, set it to custom, and say ignore camera. Let's compile that, and that should take care of our problem. So yeah, there we go. Now our camera can glide easily past our enemies. Oh, also, while we're here, we can just go ahead and delete the old target visual. Don't need it anymore, so that can just go away. And actually, when I think about it, that probably would have created some popping issues too if you had the camera at the right, or as the case may be, at the wrong angle. So yeah. The last thing we're going to do is we're going to change the main lock-on system, because right now, as you can see, when you have a lot of enemies, starting by locking onto the correct one is going to be a bit of a pain. So we're going to create a lock-on system where you're going to lock on the target that's nearest the center of the screen. So with a camera like this, rather than locking onto this guy, rather than locking onto this guy, who is technically the closest target, we would lock onto this guy, who is nearest the center of the screen. With a system like this, you're basically having an easier time selecting your target, because trying to select the target you want by just being closest isn't ideal, really. There can be many cases in which you actually want to select the target that's the furthest away. So yeah, we're gonna start doing that. So the first thing we want to do is make a crosshair. Even if you don't want to have a crosshair in your game, just having it for testing purposes is going to be really good. So you right click in the content browser, select interface, and then widget blueprint. I just named the crosshair, as you can see, W, and so just open that, and you can see here you have, well, loads of stuff. Let's just get on with it. We want image, drag it onto our canvas, select image here, and say anchor, and we want the center one. Come over to these two positions here and put both of them in 0. And on alignment, we want it to be on a half, because we want it half-lined. Half-lined in this context means that it goes to the center, because it aligns according to one of the corners. With that done, we're going to come over to brush. Just click on the arrow there, and we're going to open, just press on none, and we're going to come down to view options. So press on that, and we want to show engine content. Click on that, and once you've done that, you can come up here and search for target, and we want the target icon. So there you go. And let's see, let's adjust the size as well. It could be pretty small. We don't really need it to be big, we just need it to be visible. So let's put it on 2020. With that done, we can compile, save, and then we can go back into the third-person character, and let's find some empty space here. Up here is fine, and we're gonna add a event begin play. There we go, and we want to drag out here and add a create widget. We basically need to do this for the widget to actually be shown in the game. If you don't have this line of nodes, it won't actually appear in the game. And lastly, we want to add to viewport. There we go, and we need to connect these. So compile that, save, and let's see if it's in our view. And there you can see it. I see it at the center of the screen. Just very little. If you want to make it bigger, go back to the size I mentioned earlier, but I think that's fine. We only needed to, see where the center of the screen is. So let's move on to the actual system here. So we need to find some more empty space. Just put it down here. So we need a get world transform. There we go. And we want one for the camera boom. And you can go ahead. Actually, let's split the pin structure. Let's split the pin structure. Then let's duplicate it twice, like so. and let's get a enemy element reference. So come over here, grab one, and plug that in here. Sure. And we want a follow camera. So come up here, grab that, plug it in here. And let's get a find or look at rotation. Again, typing, not my forte. Gonna split that pin structure as well. Plug this in here and the enemy in there. And we're gonna get a float minus float. Gonna plug the yaw in top and the yaw from follow camera into the bottom. And drag out here, get a float plus float and say 360. Now you probably recognize these nodes because we've used them like 400 times before, but that's fine. If it ain't broke, don't fix it. So we need a select float. And plug the top one in here, the middle one in the middle, and the bottom one at the bottom. So we need a new variable here. So let's right click on the select float return value and say promote variable. And we're going to call that enemy angle or angel if you prefer. And let's make a custom event right now. Custom event. And call this angle check. We're going to call this later to actually start this entire system, but for now we'll just leave that. Next we want to drag out of this and say in range, and we need that to be 270 and 360. And next let's add a float minus, and we need this to be at the bottom. I'm going to say 360 at the top here as well. Excuse me. And I'm going to get a copy of, or another copy of select float. Going to plug this into the top. Going to get this return value as the condition. And we're going to drag out of enemy angle and plug that into B. Now let's add a float plus float over here. And we're going to use this later because this entire section here checks for the angle the enemy is off center of the camera in the yaw. And later when we add the pitch direction as well, we're going to plus that in here. So next we're going to add a compare float. Like so. And we're going to plug this in here. Let's do this and there, and yeah, that looks better. Move this slightly, actually. Getting way too caught up in cleaning this up. There, and let's add another. Let's promote this to variable as well, and call this off center. And lastly, we need to set our off center. Let's get that and say if it's the same or if it's less than, we're going to set it to this. Now, so we don't forget, let's just set the first instance of our off center right away. So we're going to go up to right after we press the target button. Actually, let's just go down here, drag this out, say set, control, drag this across and plug that back in. And we're going to set the initial value of this to 180. And just compile that. And let's go back down to the rest of the system here. And let's talk about what it does. So what's happening here is that when we have a enemy element, it's gonna check in degrees how far off the center of our camera it is, and if it's less than 180 degrees, it's gonna set that new value as off center, and then it's gonna check another enemy and see if it's closer to the center of the camera. If it isn't, nothing's gonna happen. This is here. We're not gonna plug this in anywhere. If it's the same, or if it's less, then it's gonna replace it. And so basically, you're once it's checking through all the enemies, it's always gonna end up with the enemy that is closest to the center of the camera. Now let's add the call for our angle check. So we're gonna come up here and we're gonna change this a bit. So let's just hold Alt and just plug this out. Move these two away. We don't need them right now. And next, let's just grab these two and delete them because we don't need those either. And then come over here to minimum distance to enable and plug that in here. Basically, what we're going to use this for now is, rather than checking for the closest enemy, we're just going to check if an enemy is in range. So with that done, just drag this out here and say angle check. And we can add a let's just go ahead and add a new custom event here right away. So say custom event. I'm going to call this angle done. Just put that over here. And we can break this connection as well. Put this up here and plug angle done in there. And we're going to take angle check and plug that into the reset instead. Add redirect now just to make the connection look clearer. And we want a get distance here. So let's right click and say get distance to, and we're going to say other target. And then we're going to say, actually, let's go over here instead and say get closest target distance and plug that in there and plug this up here. So now we're using this to say that when we have a target, if he is within range, then we're going to move up, then we're going to move up here and lock onto the target. If we just use this, then we'd have to change this logic somehow. So we're doing this to just make use of some of the old logic. Now let's come back down here and add our angle done here. There we go. And now basically the way we've made this is so that this entire section here takes place in between these two here. And I believe we're halfway there, so I think we can test this right now. So let's compile and compile. There we go. And play. And we should be able to, at least in the yaw value, which is side to side, we should be able to select the enemies that are nearest the center of the screen. Let's try for this dude over here. And yeah, that seems to work. So we've made no mistakes, or at least I haven't. If this doesn't happen for you, you've made a mistake, or I've made a mistake in explaining, which could well be the case. Now we haven't added the logic for pitch yet, which is up and down, so I don't think we'll be able to target this dude, but we may be lucky just from the yaw angle and get him anyway. Yeah, so that's basically just luck, because we might as well just get this dude when we're trying to select this guy, because we haven't added the pitch logic yet. So let's add that pitch logic. So we can just come back down over here and just grab this entire section here, except for the custom event, and duplicate that down. And then we want to swap the the pitch value here, or the yaw value, we want to swap it in for the pitch. Do that, and same over here. And we want to add a float minus float over here. Say 360 for this one, and another select float. Plug this into the top, this into the middle, and say greater than oh, there it is, greater than float 180, and say that is the condition. And we can plug this into the plus. And I believe that's it. Now, there is one more thing we might want to do, but I'm going to explain why it's just a maybe first. So let's just compile this and head into play and see if everything works correctly. So actually, before we hit play, I'm going to go back into the view here, and I'm going to add a few enemies. I'm going to put one dude here. I'm going to hit Control and Control C and Control V to duplicate him, hopefully, yes. I'm gonna put him in a straight line on that box. And actually I'm gonna grab both of these and move them a bit over because I want another dude. Control C, Control V again, and I want another dude over here. You don't need to do this. You can if you want to, but you don't need to. Because I basically want to try and show corner case now, and I'm gonna show the way a pseudo fix to that corner case afterwards, if you want to add it, but you may not want to. But we'll see in a sec. So let's hit play here, and if I now get right in the middle of these two, and I want to be closer to this dude, I'm gonna get right in the middle there. Now, I think, if I'm correct, you're going to end up locking onto the one on the higher plane, not the one furthest away, but the middle of the two. And yeah, you get that dude there. And as you see here, you're roughly in the middle, but if you go slightly closer to the dude that's closer, I believe, if I've done this correctly, you'll still get the guy standing on the square. And yeah, you do. So you see that even though the dude closer to me appears to be closer to the center of the screen, we still get the dude further away. And that's because even though the guy on the ground looks closer to me, he actually isn't. It's an optical illusion because of the perspective. Now, we can fix this if you want to. You may not want to, but I'm going to show you a way that sort of fixes this. So let's go back into the third-person character blueprint and come down here, and we're going to add a get distance to. And we're going to say enemy element. Just put that in the other actor plug, and we're going to say drag out of this, and we're going to say inverse lerp. And we want this plugged into value, and we're going to set leave A at 0, and we're going to set B as 1000. Right, and out of this, we're going to say float times float. We're going to plug this in here, and we're going to plug this in here. So what we're doing now is we're using the distance between the enemy and ourselves, and we're modifying the value we get in pitch. So it in a way that it favors enemies that are closer to us. Basically saying that if an enemy is closer to us, it's also slightly closer to the center of the screen. And this should fix the scenario I just showed you. So let's see if it worked. I'm gonna come over here, stand right up in his and we're gonna put the camera at roughly the center and then slightly closer to our guy. And There we go. Now it locks onto him instead. This system isn't perfect, but you know, it works better. So if I'm perfectly at the center, which I think that is, we're still gonna get that guy. But if you're slightly closer to this dude, you get him. And the reason I added this guy up here is because it's worse the further away they are. Though I believe with this, yeah, you still need to be like more than the halfway point to get this dude. So if you're halfway into just a little bit, you still get that guy. So that's the only real flaw in the system that I've identified, and it's arguably not a flaw because even though it looks like this guy is closer to the center of the camera, he really isn't. It just looks like he is. But yeah, so that can be an issue, but yeah, that's the only problem I've identified with this system. So I hope you like it, hope it's useful, and thank you for watching.